Hello everyone, and welcome back to the Jamaican Geologist YouTube channel. Today we're kicking off a fresh chapter in our Geology Foundation series, and this is where things start to get a little bit technical. And in this episode we're going to go deep. And by deep I mean atomic level deep. But don't worry, this series is still all about the basics. I am not trying to get overly complex. And if things feel a bit technical at times, remember, one of the goals of the series is to break down concepts in a fun and engaging way. To understand rocks, minerals, and volcanoes, we first need to understand the very things they are made of. Atoms and molecules, the elements. So we're starting small, literally, and working our way up. This episode is called Understanding the Elements. Here we're exploring some basic chemistry that every geologist or every geoscientist should know. And even if you don't go deep into geochemistry or mineralogy, this knowledge is foundational and it's essential to our understanding of rocks, minerals, and earth processes. And for many of you, this might feel like a throwback to high school chemistry. So let's get into it. So, what are elements? Put simply, an element is a substance that cannot be broken down into simpler substances by chemical means. And each element is made up of atoms, the smallest unit that retains that element's chemical properties. And atoms themselves, what are they? They're made up of three subatomic particles: protons, which have a positive charge; neutrons, which are neutral and they have no charge; electrons, which are negative, they have a negative charge. So protons and neutrons are located in the nucleus at the center of the atom, while electrons orbit the nucleus in shells or energy levels. The number of protons in an atom's nucleus determines the type of element. For example, an atom with 6 protons is carbon. An atom with 7 protons in its nucleus is nitrogen. And the atomic number is the number of protons. The atomic mass is the number of protons plus the number of neutrons. Now, which elements are most common in the Earth's crust, you may ask? Some of the most abundant include oxygen, silicon, aluminum, iron, uh, calcium, sodium, potassium, magnesium. These elements combine in various ways to form the minerals that make up the rocks. So, not all atoms of an element are exactly alike. Some have different numbers of neutrons, and these variations are called isotopes. As long as the proton number or the atomic number remains the same, it's still the same element. But the atomic mass changes when neutrons are added or removed. So let's take a look at 3 elements everyone is familiar with: carbon, oxygen, and hydrogen. So for the carbon atoms, there's carbon 12, which has 6 protons and 6 neutrons. Now the protons remain the same throughout. So in carbon 13, there's 7 neutrons, and in carbon 14, there's 8 neutrons, and carbon 14 is radioactive. For oxygen, there's 8 protons and 8 neutrons in oxygen 16. In oxygen 17, there is 9 neutrons, and in oxygen 18 there's 10 neutrons. And for the hydrogen isotopes, there's protium, which has 1 proton, no neutrons. There's deuterium, which has 1 neutron. And then there's tritium, which has 2 neutrons, and tritium is radioactive. Isotopes are a big deal in geology. We use them to reconstruct past climates and environmental conditions, to understand ancient Earth systems, pressure, chemistry, and more. And with radioactive isotopes, we can date rocks using their decay. But that's a whole other episode, right? We'll talk about that one soon. All right, so atoms bond together to form molecules and compounds. And the way they bond determines the properties of the minerals they create. There are 3 major types of chemical bonds we talk about in science. So first there are ionic bonds. And in ionic bonding, one atom gives up electrons, another accepts them. This forms oppositely charged ions that attract. And an example would be sodium chloride or table salt. Then there are covalent bonds, and here atoms share electrons, and these are very strong. And an example would be diamond, which is made of pure carbon atoms bonded together covalently, of course. And then there are metallic bonds now, which electrons are free to move around, and this gives metals like copper their conductivity and their malleability. So you might be wondering, why are we talking about atoms and bonds on a geology channel? This isn't a chemistry series, right? Well, it just goes to show how diverse geoscience really is. I mean, geochemistry can get complex, but these are the basics, and we all need to know in order to understand how the earth truly works. It matters because atomic structure and bonding is essential in determining properties of minerals like hardness, like the difference between graphite and diamond, or crystal shape or cleavage, fracturing, electrical conductivity, and we'll get into all of these things in our next episode on minerals, and that should be very exciting. All right, so to sum up everything, everything we study in geology, from the massive mountains to the tiny grains of sand, they start at the atomic level. Understanding atoms, isotopes, and chemical bonding gives us the tools we need to understand minerals, rocks, and even planetary evolution. And in our next episode of the Geology Foundation series, we'll move from the atomic world into the world of minerals. What is a mineral? How do you identify them? Why do some shine and others crumble? We'll get into all of that and more. So if you enjoy this episode, don't forget to like, share, and subscribe to the Jamaican Geologist. And with that, I'll see you next time. Take care.